5.1 number 30 is asking us three different questions right here, and they want us to compute each one of these sums. Now, computing a sum with a sigma notation can be scary depending on the numbers involved, but as I was writing these out, I looked at all three of them and thought, you know what, they're not that bad, because what I'm really doing is focusing on the starting value of the variable in the summation and the ending value. So if we're going to start here on A, letting j equal 3, and end after j is 4, that's only two values that I've got to compute right here and then add together. So I don't think this one is going to be awful. All right, guys, here we go. We're going to begin by letting j equal 3 in this expression right here, which is going to get us the sine of 3 times pi over 2. So that'll be 3 pi over 2. I'll evaluate that on the next step down, but for now I'm going to leave it right there. A sigma, a summation, means that we are adding now term by term, and now that we've let j equal 3, now we take it up by the next integer, and we're going to let j equal 4 now. So this will become the sine of 4 times pi over 2, which is going to be a 2 pi. And what just happened? We let j equal 4, so we're done. Those are the only two terms that we need to compute and then add together. So 3 pi over 2 on our unit circle is pointing straight down. Sine is our y-coordinate. So sine of 3 pi over 2 is -1, and the sine at 2 pi is going to be 0. So our answer to part A there looks like it's going to be -1. On to the second part. This one's a little tougher because we're starting at 3, and we're going to let k be 3, then 4, then 5. So this one's going to have three terms, a little bit more complicated than the last one. So here we go. We begin by letting this k equal 3. So that's a 1 over 3 minus 1 is going to be 2. We'll add to that now. We increase our 3 value here for k by 1, and we make it 4. 1 over 4 minus 1 is going to get us a 1/3 there, and I think I see a pattern. And now we'll let k equal 5, where that denominator will become a 4. So again, we let k equal 3, then 4, then 5. Those are the three terms we were looking for. Now, I suppose we need a common denominator right here, and I think that's going to be 12. So you guys could do this on your calculator if you wanted to, but it's probably faster just to do it by hand, I think. So that's going to be a 4/12, and that's going to be a 3/12 there, which looks like we're going to get 13 over 12 for the value of that summation. Okay, and now on to part C right here. Again, we're starting with j equals 0, letting j equal 1, and then ending after j is 2. So this will be three terms again, just like example B was. And what's going on in our expression here? It's 3 to the j minus 1 power. Well, we start off with a j value of 0, and 0 minus 1 is -1. And then we'll add to that 3. Now we would let j equal 1, and 1 minus 1 is 0. And we'll add to that 3 to the, we let j equal 0 and 1, now 2. And 2 minus 1 gives me a power of 3. So what do we have here, guys? 3 to the negative first power is 1/3. 3 to the 0 power, be careful here, is 1. And 3 to the first power is 3. So it looks pretty plainly here, guys, like we've got 4 and 1/3 for the answer. Or if we wanted to write that a different way, 13 over 3. I'd be good with either one of those, obviously. So I suppose I could have circled that one too. And in AP Calc, if you're going to round to a decimal, you'd have to be accurate to 3 decimal places, but that would work. So you could also get 4.333, and even though I don't like the rounding unnecessarily, the AP graders would give you full credit for it. So that's how you do number 30.